This is Physics 2212 Lab 1 Charge Tapes by Melanie Weaver. To begin, friction causes electrons to escape and leave the charges on materials. In this experiment, we used that knowledge to make a piece of tape float above another. We can calculate the charge of the tape using a few physics concepts such as Coulomb's law and the conservation of momentum. As for the experiment, the goal was to use charged U-tapes to calculate the charge on the one that floated. The length of the tape was 18.5 centimeters, the width was 1.9, the mass was 0.185 grams, and the distance between the floating U-tape and the one that made it float was 2.1 centimeters. I expected the U-tape to repel each other and attract a neutral object, and that's what happened. And with the interactions with the negative pen, if the tape was positive or neutral, it would have attracted it, and if it was negative, it would have repelled, and it repelled, so you know that the tape is negative. Since the tape was floating, you know that the net force is 0, and the electric force from the tape is acting on it, as well as the gravitational force from Earth, and that is labeled in the free body diagram. And now for the calculations. The gravitational force ended up being 0.001813 newtons. For the electric force, you used the equation EQ, which ends up being kq squared over r squared, and you set those two equal to each other to find out that the charge was negative 9.425 times 10 to the negative 9th coulombs. And then you divide that by the charge of one electron, which is 1.602 times 10 to the 19th, and you find out that the total number of excess electrons is 5.883 times 10 to the 10th. It was given that the diameter of one atom is 1 times 10 to the negative 10th, so to find out the total atoms per tape, you multiply that number by the length and by the width, and then you multiply those two together to end up getting 3.515 times 10 to the 17th atoms per the tape. And then to find the ratio of the number of electrons to the number of atoms, you just divide those two numbers together to get 1.674 times 10 to the negative 7th excess electrons per atom. And now on to the coding section. I used a function to find the electric field between them, and then I used simple equations to model the rest of the code. For the model, the purple sphere represents the top tape, the orange represents the bottom, the magenta arrow represents the force of gravity, while the yellow represents the electric force, and on the bottom I printed out the calculations that I found to prove that the net force is 0. Now on to the questions. The assumptions made are ignoring air resistance, treating each tape as a point charge with the same net charge distributed evenly throughout in the center, and you had to assume that one atom fit in the height of each tape, so basically that the atoms are flat in order to calculate the amount per the whole tape. If electrons had a positive charge and protons had a negative charge, the observations would be the exact same. The charge on the tape would be the same magnitude but opposite sign, and the only change in the observations would be that in reaction with the pen, which is negatively charged, it would now attract it because with the excess of positive electrons, it would make the tape positive to then attract the negative pen. Important to handle the tapes as little as possible because every time you touch the tape, electrons will jump from the tape onto your hands, then reducing the charge on the tape, and the more that happens, the less the tape will react, and the worse your observations will be because the tape is no longer charged. In conclusion, we observed the effects of electric force on charged tapes, and through that we saw the balance of gravitational and electric force, which caused a net force to be 0 and an object to hover. We also proved that opposite charges repel each other and like charges attract through how the U-tape reacted. To conclude that the net force was 0, we used our knowledge that unmoving objects will have a net force of 0 as shown in Newton's first law, and through all those observations we were able to find the charge, amount of atoms, and amount of excess electrons in the floating tape. And thank you for watching. That is my Lab 1.